This section learns about the map interface. The map interface. This is different from the collection subinterface and its implementation class. The map interface is a two-column collection, which means that it stores elements in pairs. That means it's a mapping relationship. Key is the key. Value is the value. So key can't be duplicated in the map. When accessing elements of the map, you just need to specify the key to find the corresponding value. So it's a kind of mapping relationship. That's why it's called map. Map from the English word has the meaning of map. It also means mapping. We can actually draw a map to make a demonstration. You can see let's call the left-hand side a key. The right-hand column is called the value. Then the key and value have a one-to-one relationship. But you can't have the same duplicate key. Value is allowed to be repeated. This value can be the same. This mapping refers to the value that the key points to. A key corresponds to a value. The key can't be duplicated, but the value is allowed to be the same. This is a fundamental characteristic of the map. The value is found by the key. These methods are commonly used. So much for the features and methods of the map collection. Next, we'll learn about HashMap. HashMap is the core implementation of map. Provides operations to add, remove, and find elements from the map. So first of all, let's look at. Since we have a map, that means that key cannot be duplicated. Value allows duplicates of. How to use the HashMap. We start by creating a HashMap collection object, and then call its put method. The get method is the query. The query is to retrieve the value from the key. We can also make changes. That is, when the key is the same. We'll overwrite the previous value. There are still only 3 elements in the map, except that the second edition of Zhao Liu replaces the original value of Wang Wu. This confirms that the keys in the map must be unique. They can't be duplicated. So in a nutshell, same key, overwritten value. Iteration, on the other hand, first iterates over all the keys in the collection, and then get the value based on the key. That's the set of its keys. And then get its keys. We then use get to find the value. This is an iterative way. So first we get the relationship of all the mappings in the set, and that mapping relationship. This can be done using the entry set method. You get a collection of key-value pairs. So, since the key is unique, then its key-value pair is also unique. For example, values takes all of its values. Size is a number. Contain key indicates whether the value is contained. And then remove means remove the key-value pair. Come on, let's go through some examples. We're going to show you how to do it. The first one we've learned is put. This refers to adding key-value pairs to the map collection. Get is to get the corresponding value from the key. Then next say the third. Contains the name contains key. Indicates whether the specified key is included. The value returned is a Boolean type. That is, it's inclusive. So if it's not, you say 10 has this key. False. Whether the fourth contains value. that if Zhang Sanfeng does not include, then it's false. Remove means to remove a key-value pair. Then we look at the demo. Finally, about its iterative operation. There is also an additional modification operation, if the put key values are the same. I'm going to put the new value. Overwrite the previous old value. Okay, let's do that. Finally, iterate over a collection of maps. You cannot use the for loop directly. And iterator. There are two ways to iterate. The first is to get the set of all the keys. Let's do that. Method 1 is to get all the keys first. Let's do that. Another way is to get a set of key-value pairs called an entry set. Let's do that. Method to obtains all key-value pairs. Let's do that. You can also get the key-value pairs at this point. We'll do that again when we come back. Let me draw it for you. This blue one is called entry. This red one is called chi-set. Method 3 gets the set of all values. The set of keys is called a chi-set. The set of values is called values. A key-value pair is called an entry set. The set of values refers to this yellow part. Let's do that. So much for map iteration and its common methods. Next, we'll learn about linked hashmap. It maintains an order of additions and acquisitions. Then we can use the hashmap to store some values, and then through linked hashmap to store some values. Then we can compare. Linked hashmap is similar to linked list. It is using a bidirectional linked list. So let's do that. In fact, we can directly the map this printout. In fact, it corresponds to this order. This is because it has a default ordering. So if we use Lincoln's Korean cuisine, we can maintain this order. So let's do that. Okay. Is it in the same order as you added it? The reason why it can make the order of store and retrieve the same is because the underlying data structure uses a two-way link table. So about the use of this, that's all you need to know.